This is the first time in human history that we've encountered a visitor from another star system. With an astonishing speed, this object has baffled scientists with its mysterious ability to accelerate, something that completely defies everything we've known. Could this be alien technology, or simply a natural cosmic wonder? It has no tail like a comet, yet it accelerates in a puzzling way. Its light reflectivity is 10 times higher than that of ordinary asteroids or comets. A professor from Harvard even proposed a shocking hypothesis. Could this be a probe or a light sail crafted by an extraterrestrial civilization? The appearance of this object instantly ignited endless debates within the global scientific community. In a special video, I will take you on a comprehensive exploration of the latest discoveries about Oumuamua, the mysterious visitor from beyond the solar system, and together we'll decode the enigma surrounding it. On October 19, 2017, a telescope at the Haleakala Observatory in Hawaii detected a bright object moving at high speed. At first, no one paid much attention to it. After all, our solar system is not completely closed off. On its far edge, beyond the Kuiper Belt, lies the Oort cloud, a hypothetical region filled with icy celestial bodies that surrounds our solar system. These bodies are sometimes affected by the gravitational pull of passing stars, which can nudge them from their original orbits. Some are pulled inward toward the solar system, becoming long-period comets that we can observe. Others are completely ejected and become wanderers among the stars. Similarly, other star systems in the universe may have their own comet reservoirs. As stars move through the Milky Way, their gravitational fields interact, often flinging celestial bodies away from their home systems, or even capturing wanderers from elsewhere. Scientists estimate that every day, tens of thousands of such small objects could pass inside Neptune's orbit. So when Oumuamua was first discovered, astronomers naturally assumed it was just another wandering comet from afar, and promptly gave it a cometary designation, C2017 U1. However, it wasn't long before a sense of strangeness began to emerge. Despite careful observation, astronomers couldn't detect any signs of dust or gas, both of which are essential characteristics of a comet, typically forming what's known as the coma, a glowing halo, and the comet's tail. A comet without a soul? That was truly bizarre. And so, something unprecedented in history occurred. Oumuamua was stripped of its comet status and reclassified as an asteroid, given a new designation, A2017 U1. This marked the first time in human astronomical history that such a tidal switch had happened in the classification of celestial objects. But that wasn't the most astonishing part. The real shock came when scientists calculated its exact trajectory. The results sent chills down everyone's spine. Its speed was too fast. So fast, in fact, that it could overcome the powerful gravitational pull of the sun, moving on an open hyperbolic trajectory, zooming through the solar system, never to return. This was undeniable evidence that Oumuamua was not a native resident of the solar system. It was a traveler from afar, a truly interstellar object in every sense of the word. To commemorate this historic discovery, astronomers gave it a name rich with Hawaiian flavor, Oumuamua, which means the first messenger from afar, or the scout. The International Astronomical Union, IAU, promptly created an entirely new classification for this type of celestial object, the prefix I standing for interstellar. Oumuamua became the very first member of this brand new cosmic family, designated as I2017 U1. This marked a milestone, a new chapter in humanity's journey to explore the universe. However, no one expected that this distant messenger would bring more mysteries than answers. As soon as Oumuamua's interstellar identity was confirmed, scientists realized that its strangeness went far beyond anything they had anticipated. From its shape to its motion, every aspect raised serious questions. The first mystery: what exactly is its shape? Oumuamua is very small, with its length estimated to range from 100 to 1,000 meters. Yet its shape is extremely bizarre. By analyzing the dramatic fluctuations in its brightness over a 7-hour rotation cycle, scientists speculated that it was either shaped like a stretched-out cigar, with a length-to-width ratio possibly as high as 10:1, or it had an incredibly flat form, resembling a pancake or a flying saucer. Whether cigar-shaped or disc-like, Both forms are highly unusual and unlike anything typically produced by natural processes in celestial bodies. Even stranger, Oumuamua didn't appear to rotate stably around its axis. Instead, it seemed to tumble chaotically, wobbling and spinning erratically, like a malfunctioning top staggering through space. The second mystery: where did it come from? If it were an asteroid, then in theory, such objects usually form near the habitable zone of a star. So how could it have been flung from its home system with such force that it traversed unimaginable distances across the universe to reach our solar system? Could this be the aftermath of a catastrophic planetary collision of apocalyptic proportions? Or could it be a piece of space junk ejected during a massive planetary system cleanup operation? If its true nature is that of a comet, but its surface has long been covered by a thick layer of dust that hides all its typical identifiers, then the pressing question becomes, how long has it been drifting alone through the cold void between stars? A few million years, or perhaps even billions. The third mystery: the ghostly thrust. This is the key issue and the most perplexing aspect of Oumuamua's journey. In September 2017, it passed through its perihelion, closest point to the Sun, at a staggering speed of 87 kilometers per second. According to the laws of gravity, its speed should have gradually decreased as it moved away from the Sun. But observational data showed that this deceleration was much less than expected. It was as if some invisible force, weak yet persistent, was gently pushing it from behind, subtly countering the Sun's gravitational pull. This non-gravitational acceleration, though small, around 17 meters per second squared near the Sun, was absolutely real, and it couldn't be explained by gravity alone. Acceleration always requires a pushing force. So where was this force coming from? The fourth mystery: unusual reflectivity. At first, scientists assumed it might just be a dim, dark rock. But then, infrared observation instruments such as the Spitzer Space Telescope revealed a surprising finding. Oumuamua exhibited unusually high reflectivity, 10 times brighter than typical asteroids or comets in the solar system. Its surface reflected light like polished metal, glossy and anomalous. So what exactly are we dealing with here? A bizarrely shaped object with mysterious origins, an unusually bright and shiny surface, and most of all, the ability to accelerate without any visible thrust mechanism. All of these traits combined to make Oumuamua seem truly extraordinary, even eerie. The scientific community exploded with debate. A flood of hypotheses and theories emerged, clashing fiercely within the research world. Faced with this unexplainable acceleration, scientists poured their efforts into uncovering the cause. Could it be due to the solar wind or the pressure of solar radiation? But calculations revealed that for an object the size of Oumuamua, these forces were far too weak to account for the observed increase in velocity. Then what about the most plausible explanation: outgassing, as seen in comets? Frustratingly, all observations showed that it was spotless. There were no signs whatsoever of gas or dust being expelled. Backed into a corner, theorists began to split into two major camps, triggering a fierce and thrilling scientific debate. The first camp, challenging traditional views toward the extraterrestrial technology hypothesis. Leading this school of thought is Professor Avi Loeb from Harvard University. He made a groundbreaking claim: the simplest and most logical explanation for Oumuamua's strange behavior is to acknowledge it is not a product of nature. Professor Loeb calculated that if Oumuamua were an ultra-thin object, only a few thousandths of a millimeter thick, as thin as a sheet of paper, then the pressure from sunlight alone would be sufficient to produce the mild acceleration that we observed. However, such an extremely thin sheet-like structure is virtually impossible to form naturally. Therefore, Professor Loeb proposed a bold hypothesis. Oumuamua could be a light sail, a propulsion device built by an extraterrestrial civilization designed to travel between stars using stellar radiation as thrust. And by chance, we happened to spot it just as it was gliding past our solar system. This hypothesis was so shocking that it immediately captured intense attention from both the media and the global public. The second camp, searching for natural explanations within existing physics. Representing this perspective are scientists like Daryl Seligman from Cornell University. Not everyone agreed with Loeb's alien technology theory. Seligman and his colleagues sought to offer a natural explanation within the bounds of current scientific knowledge. Initially, they proposed the hydrogen iceberg model, suggesting that Oumuamua might be composed primarily of solid hydrogen. Since hydrogen only freezes at extremely low temperatures when approaching the sun, it would sublimate, transition from solid to gas, generating thrust. At the same time, hydrogen gas is transparent and hard to detect, which could explain the absence of any visible outgassing. Sound plausible? Not so fast. Professor Loeb quickly countered. Solid hydrogen is too volatile. On a journey spanning millions or even billions of years through interstellar space, even the faint radiation from distant stars would have been enough to vaporize it entirely. Thus, it could not have survived intact all the way to our solar system. Faced with this strong rebuttal, Seligman's team did not back down. Instead, they refined their hypothesis by collaborating with Professor Jennifer Berdner from the University of California, introducing what they called the dark comet model. According to this revised theory, Oumuamua's core could still consist of water ice, similar to ordinary comets. However, during its formation and prolonged interstellar voyage, it may have absorbed and trapped large quantities of hydrogen molecules into its structure, much like a sponge. This process has been shown to be plausible both in laboratory conditions and theoretical models. Moreover, the high radiation environment of space, including exposure to cosmic rays, could further facilitate this hydrogen trapping mechanism. As Oumuamua approached the sun and its temperature rose, the crystalline structure of the internal water ice began to change. This transformation caused the previously trapped hydrogen molecules to gradually be released, slowly, steadily, and completely invisible to the naked eye. The release process was so gentle that it didn't carry any dust, yet it generated just enough thrust to explain the mysterious acceleration. Based on this hypothesis, scientists proposed a completely new type of celestial body, the dark comet. These objects produce non-gravitational acceleration through the release of invisible gases stored within them, such as hydrogen. As a result, they exhibit none of the typical features of traditional comets: no glowing coma, no distinctive comet tail. The scientific debate over the true nature of Oumuamua became increasingly intense. Each side stood firm in defense of its viewpoint. Professor Loeb argued that the dark comet model still had unresolved issues, both mathematically and physically, and he remained steadfast in his belief that Oumuamua was an alien light sail. Yet just when the debate seemed to reach a stalemate, Seligman's group made an unexpected breakthrough. They began to wonder, if the dark comet model is correct, could such gas-releasing objects, using invisible propulsion, actually exist within our own solar system? They meticulously combed through the full database of known asteroid observations, focusing on those with unusual orbits that showed signs of weak, non-gravitational acceleration but no visible outgassing. And they found them. Not too many, not too few. Exactly 6 small near-Earth asteroids matched these criteria. These objects were tiny and at first glance unremarkable. In the past, their slight and unexpected accelerations had been dismissed as measurement errors or unexplained anomalies. But this discovery was of immense significance. It suggested that the invisible thrust phenomenon observed in Oumuamua might not be rare at all. It could, in fact, be happening right here in our cosmic neighborhood. And this served as powerful indirect evidence in support of the dark comet theory. Even more exciting was that among the 6 suspected dark comets, one stood out, 1998 KY26, which had already been selected by Japan as the next target for its Hayabusa 2 probe. After successfully collecting samples from the asteroid Ryugu in 2020, Hayabusa 2 is now on a new mission, chasing down 1998 KY26. It is expected to fly by this asteroid at extremely close range around the year 2031. At that time, we'll have the unprecedented opportunity to directly observe and confirm whether 1998 KY26 truly emits invisible gas, just as the dark comet theory predicts. If successful, this mission could mark a major turning point in confirming whether the dark comet model is truly valid. It may become the key to unlocking the mysteries surrounding Oumuamua. However, despite the hope surrounding the exploration of 1998 KY26, it is still not Oumuamua. The mysteries directly linked to this first interstellar messenger, especially its origin and true composition, remain unresolved. All we know for certain is that Oumuamua came from a very distant region of the universe. Astronomers have traced its trajectory backward and estimated that it may have originated from the direction of the constellation Lyra, even identifying several stars that could potentially be its home. But none of these leads can be confirmed with certainty. Currently, Oumuamua continues its journey, racing away at 26 kilometers per second. It is moving farther and farther from the solar system and is now more than 6 billion kilometers from Earth, in the region of space where the Voyager 1 probe once captured the famous pale blue dot image. Oumuamua has gone well beyond the reach of any telescope on Earth. Will we allow these mysteries to fade into the dark with Oumuamua, unanswered forever? Some scientists, unwilling to let go, have proposed an idea so bold it sounds like science fiction, launching a spacecraft to chase after Oumuamua. It may sound thrilling, but executing such a mission would be an enormous challenge. The first obstacle is speed. Oumuamua is simply too fast, and our current rocket technology can't keep up. The second problem is deceleration. Even if we manage to catch up, how can we slow down precisely at such extreme velocities to orbit or even land on the object? This is a monumental technical challenge. The third challenge is perhaps the most daunting of all. How do we pinpoint an object only a few hundred meters long, tumbling chaotically in the vast, dark emptiness of space? It's like finding a needle in a cosmic haystack. Nevertheless, these difficulties have not dampened the scientific community's enthusiasm. The most prominent initiative is Project Lyra, an ambitious plan to design potential mission scenarios to intercept Oumuamua. The core of these scenarios involves gravity assist techniques, essentially playing cosmic billiards. The spacecraft would perform a series of flybys past Earth, Venus, Jupiter, and even skim close to the Sun, using their gravitational pull to gain speed or adjust trajectory. One of the proposed options is to launch the probe sometime in the 2030s. If all gravity assist maneuvers go precisely as planned, the spacecraft could catch up to Oumuamua around the year 2048. The mission designers believe that, given Oumuamua's uniqueness and immense scientific potential, such an interstellar chase would be well worth the effort. Sooner or later, this cosmic pursuit may become a reality. Of course, launching a spacecraft to chase Oumuamua would require an enormous budget and carry considerable risk. So, do we have any other options? Fortunately, astronomical observation technology is advancing at a breathtaking pace. The upcoming Vera C. Rubin Observatory, soon to be operational, will possess unprecedented sky surveying capabilities. It's estimated that Rubin could detect dozens to even hundreds of interstellar objects like Oumuamua every year, possibly even warning us months in advance of their arrival. This would provide a massive data set, allowing us to study entire populations of interstellar visitors, rather than just isolated cases. Meanwhile, the European Space Agency, ESA, is preparing to launch its Comet Interceptor mission, a comet chaser that will wait in space, ready to spring into action. Scheduled for launch in 2029, this probe will be placed on standby. When a long-period comet or a new interstellar object enters the solar system, it can be swiftly deployed to intercept and observe it up close. These promising projects will undoubtedly deepen our understanding of interstellar bodies. However, they are no substitute for studying Oumuamua itself. Each interstellar object may carry unique messages from its home star system. But Oumuamua was the very first one humanity ever encountered, and crucially, its behavior was especially bizarre. The secrets hidden within it may also be exceptionally unusual. If we choose to wait for the next Oumuamua, we might eventually meet it. But the one-of-a-kind, irreplaceable mysteries of this first messenger may be lost forever. So ultimately, what is Oumuamua? A dark comet cloaked in disguise? A fragment of a light sail crafted by an alien civilization? Or an entirely new astronomical phenomenon beyond humanity's current understanding? Truthfully, without further direct evidence, science cannot yet offer a final answer. But the quest to solve the mystery of Oumuamua is more than mere curiosity. It is humanity's effort to understand its own place in the universe, to delve deeper into the origins of life and the evolution of the cosmos. No matter which path we choose, whether embarking on a bold, risky interstellar pursuit or patiently awaiting the next messenger to pass by, this exploration remains a grand journey, one that reflects the brilliance and courage of humankind.